So let's get started on probability. Unfortunately, I don't think we'll be able to finish probability, but I will be able to sort of introduce some of the key concepts in probability. And you guys feel free to go through the notes. It is reasonably detailed. But if you do have any questions and there aren't any concepts that don't make sense when you're going through the notes yourself, please shoot me an email. Okay, so let's sort of talk about the definitions in probability. So consider a scenario, right? You're going to roll a fair six-sided die, right? So the rolling of that dice is a random experiment because you don't know what the outcome is going to be. It's entirely stochastic, right? You just throw it and you let nature take its, path, right? And each experiment has 6 different outcomes. Each outcome corresponds to each side of the die. You can get 1, 2, 3, 4, 5, or 6, right? And the outcome is a possible result of a random experiment. So these are just some terminologies to know. And the event is a group of possible outcomes, right? And the sample space is a set of all the possible outcomes. So in this case, our sample space, like I mentioned before, is going to be 1, 2, 3, 4, 5, and 6, right? Because those are just any one of the outcomes that can occur. And the curly brackets that are used in this case denote a set, right? Very different from the different types of brackets you've been exposed to, like as the square brackets and the round brackets, right? These are different. These just denote a set. Some set notation, which I hope you guys are quite familiar with. You might have seen it in function notation as well. So intersection is the list of outcomes that are in both A and B, and it's reasonably useful to represent that with a Venn diagram, right? So intersection is that shaded area there. The union is the areas that are in A or B, right? So it's not super specific. So it's either in A or it's in B. So this is A or B, right? The complement of A are the outcomes that aren't in A. So if I have A on the left here, the complement of A is B and everything, around A, as long as it's not touching A. A null set, or, a 0 with a dash through it, is a set that is empty. So that would just, look like this, right? Kind of sad, nothing in it. And epsilon is just used to list, the whole sample space of a random experiment. Though I don't see it too much, so I wouldn't stress about it too much. I haven't really seen null set that much either. I've maybe seen it in one question or something. It's not assessed too much, but union and complement and intersection pop up all the time. So if you could only memorize 3 of these, I'd say just memorize intersection, union, and complement. But I would recommend knowing all of these regardless. Okay, let's sort of practice our set notation, figure out what all of this is. So if we have A is a set of 1, 3, and 5, and B is a set of 1, 2, 3, and 4, and the full set epsilon is 1, 2, 3, 4, 5, and 6, list the following sets. So A intersection B is just, the common values. The common values between A and B are just 3. Right? Sorry, I suck at doing the squiggly lines. What about A union B? That's just all the values in both of them without repeats. So we've got 1, 2, 3, 4, and 5. Right? And not A is just everything that's, or complement of A is just not A, right? Anything that's not an A. Right? So it won't be 1, 2, or 3. It'll be 4 and 6, if I'm not mistaken. So hopefully that makes sense. Okay. Like I showed you guys earlier, a way we can visualize these sample spaces are through Venn diagrams, right? So the probability of A is just given by the yellow bit. A intersection B, like earlier, is also just given by the yellow bit. The intersection between not A and B is the yellow part. And a handy formula to know is sort of, well, how can I figure out the union, right? The way we work out the union is that we add the probability of A to the probability of B. Right? So I'll go back here. And so we can see that A already contains this region. And when we have B as well, B would contain this region as well. So if I add A and B, right, I get a doubling up of the intersection, right? So that's why we subtract the intersection, because it doubles up. By subtracting the intersection, we get A union B. Okay. Let's say the intersection between A and B is a null set, or there's no numbers in there, right? That would mean that these two events are mutually exclusive. So what does mutually exclusive mean? Basically, no overlap between the two things, right? Um, yeah. So generally, a tricky concept. I think a lot of people get it confused with independent events, which is something I'll also talk about. Um, with Venn diagrams, we generally put a box around the Venn diagrams, like so, and that contains events that aren't outcomes that aren't part of either event, right? So, from the question earlier, the same sort of sets that we're using, we can see that, outside the Venn diagram in the box, in the common area of 1, 3, in A, we only just have 5 that's unique. In B, we have 2 and 4, but we also see we have 6, which is not included as part of any of these sets. Okay, how do we work out the probability of something happening? So these are some of the fundamental properties of probability. So the probability of an outcome is the number of favorable outcomes divided by the number of total outcomes. For example, if I flip a coin 10 times, right, and I'm trying to, let's say my favorable outcome is the probability of getting, getting like tails, right? If I got tails 3 times, let's say it was like an unfair coin that's like being weighted. If I got tails 3 times out of the 10, the favorable outcomes was 3, total outcomes was 10. So the probability of tails is equal to 0.3 or 3 on 10. Either or, doesn't matter. The probability of all outcomes must always be between 0 and 1. Why? Well, 1 means certainty, right? So 1 is certain and 0 is impossible, right? We can't be less possible than impossible, right? We can't be more certain than 100% certain. So that's why probability is always between 0 and 1. And all outcomes must sum to, the probability of all outcomes must sum to be 1, right? If I have an event, or like, let's say I flip a coin, right? Well, it makes sense that one of those sides is going to land, right? So then that means that there's 100% chance of that coin landing, right? Which is true, I'd hope. Um, so even if it's like a weighted coin, like the probability of tails is 0.3, and the probability of heads is 0.7, right? They should still add up to 1, right? It doesn't make sense for the probability of heads to be 0.8 because that means there's a 110% chance of that coin flipping on either side, right? You can't be more certain than certain, right? So yeah, probability must always sum up to 1 of the outcomes. Conditional probability. This is like quite cool, I think. It's like calculating the probability given that an event has already occurred, right? For example, it's like the probability of breaking a dishwasher given like the probability of me breaking a dishwasher given that I suck at repairing dishwashers, right? So it's a probability that 2 events that sort of impact each other um, occur, but one of them has already occurred um, before the other, so that results in that impact. Um, Maybe the probability of someone's height, given that they have had their first growth spurt, right? The probability of someone's height being greater than 180 centimeters, given that they've had their second growth spurt, is like a conditional statement, right? And this is read as probability of A, or the probability of event A given B. So the given part is always second. So often they'll word like given a thunderstorm has happened, what is the probability that it has rained, right? That sort of stuff. This is a good example. Given that it has rained the day before, what's the probability that it will rain the next day? Right? So this isn't explicitly in the study design, but I think it's useful to know, just because it's a reasonably good way to sort of problem solve, right? So basically, it's a probability table or a Kano map. It shows it's reasonably good for 2 events only, I think. If you have more events, it gets a little bit hectic, but you can sort of fit that in. If you have A and B, right, then their intersection is given in this box, and then the intersection of A not B is given in this box, and so on, right? These two will always sum up to include the total probability of B. These two will sum up to include the complement of B. These two will sum up to include probability of A. These two sum up to equal not the probability of A. And all of this sums up to equal 1. So hopefully that makes sense. But yeah, that's sort of just what I went through. So let's sort of go through this question. So the probability that Cynthia walks to school when it is raining is 0.1. So walking is an event. So with probability, it's always good to sort of label everything, just because that helps when it comes to doing these sorts of questions, right? Clears the clutter, I guess, around all these random words. Like you don't need to know that like the person's name is Cynthia. What you do need to know is the probability of it, of her walking to school and it raining, right? So this says the probability that Cynthia walks to school when it is raining. So this is an intersection event, right? She's walking to school and it's raining. So that must be the intersection event. So that's there, right? The probability that it doesn't rain is 0.6. So the probability that it's the complement of rain is 0.6. That would go in that box there, right? And the probability that Cynthia walks, so the probability of W, is equal to 0.7. So this goes here. The rest of it you can work out, right? So here, this is just 1 minus 0.7. This is just 1 minus 0.4. 1 minus 0.6. And then here, you can work this out by 0.4 minus 0.1, right? And so on. So the question asks, it is raining today, right? So we're looking at the rain category. What is the probability that Cynthia walks? Well, the probability of Cynthia walking, given that it's raining, or I do need to sort of erase something, sorry. So what they've told us is that it's raining today. What is the probability that Cynthia walks? So this is a conditional statement, right? They've given me a piece of information. They've told me what is the probability that Cynthia walks given that it's raining, right? So the intersection of this is walks with raining divided by the probability that it's raining. And so now I just enter all the values from the Carnot map, right? The intersection between them is 0.1, and the probability that it's raining is 0.4. So this just simplifies to be 1 on 4. So hopefully that makes sense. The way I recognize that it was conditional probability is because they gave me this statement here. They told me that it's raining. I was going to go calculate this given that something has already occurred. Okay, so I might leave it there. So I'll sort of talk about, this is just a couple techniques, but they're reasonably easy to go through, I reckon. If you guys have any questions about that sort of stuff, feel free to shoot me an email. But I really do want to go through how you guys can sort of prepare for next year, which I think is, reasonably stressful being in year 11, going into year 12. It's sort of, your final year of high school, and, the pressure sort of packs on. So how can you prepare for 3-4 methods? Well, the simplest way to do so is to put in the work in year 11, right? There's a lot of overlap between year 11 content and year 12 content. If you're on top of your work in year 11 and you know all the concepts reasonably well in year 11, you'll relearn them again next year, and you'll already be ahead of the others who sort of slacked off in year 11 because they thought, well, this doesn't count, and only year 12 counts, right? So being ahead in year 11 helps a lot, right? Because it lets you, build a strong foundation for year 12 when they give you harder questions, just assessing the same content, right? So it's really important, that you study hard, stay organized, and if you do struggle with anything, make sure you ask for help. That's why your teachers are there, just to help you, more or less. So if you've got any questions, ask your teachers. Feel free to ask me as well. I'm more than happy to help with this sort of stuff. Other things you can do is, you don't need to do every question from the textbook, but I would suggest doing a lot of questions from the textbook, just because it includes a lot of variety, right? The more variety of questions you can tackle, the more you sort of build like a mental library of like problem solving techniques, right? So when you see a question that maybe you haven't seen before, but you've seen similar questions, or questions that require the same pattern of thinking, you'll get it just that much quicker. And I can't, like explain just how much that helps knowing, having done a variety of different question types. Know your CAS shortcuts. Um, I'm primarily familiar with like the TI Inspire, and you can actually use numbers. So like if you press menu and then you can press numbers instead of scrolling through it to get to places, and it actually saves a little bit of time. Um, and try not to use notes during practice tests, and that just simply lets you know what you need to revise. Another thing I'd suggest is also making a mistakes logbook. So as you go through year 11 and go through year 12, collect mistakes you've made, more or less. Like every time you get a question wrong, figure out why you got that question wrong and collect it and put it somewhere. That reasonably, like that's quite a reasonable thing to do, and it's not that hard. But over time, you can sort of crack down on your mistakes that you're consistently making and actually see improvement and makes less silly mistakes and get better in the long run. And in your exam, um, this year and next year, um, I'd recommend, try not to waste too much time on questions you don't know how to do, and try use reading time effectively. Skim the paper, sort of find the questions you can do, find the questions you can't do, tackle the questions you can do first, and then come back at the end and do the questions that you don't know how to do, only if you have time. Because sometimes it's just a matter of thinking through a question and you'll suddenly know how to do it. But anyways, thank you guys for coming today and hopefully participating in chat. Hopefully you guys learned a lot today and found this informative. Again, if you have any questions, feel free to shoot me an email at aj@tutesmart.com, and I'll get back to you as soon as possible. But yeah, best of luck for year 11 and best of luck for year 12. See ya.